Oh well. When the shadow radius is depends on the distance to the shadow caster. There's a nice GPU Gems article on that. Maybe some cluster shading to support a lot of lights, maybe some cloth simulation on these curtains, maybe some reflections. I don't know. There are some nice nice ways to make cube map reflections look good, like parallax corrected cube maps and stuff like that. We'll see. And maybe some GI, maybe some global illumination. I have never done any GI, so I don't know. We'll see. So we're doing a very basic real-time path tracer for a broader audience. Yeah, easy. I'm afraid we'll start with extremely boring stuff today. Yeah, so my plan for today is to just set up WebGPU, make a triangle, maybe move some camera around, something like that. I don't know how many streams I'll be able to pull off with this thing. I don't know whether I'll do some stuff off stream. I probably will, but we'll see. Yeah, something like that. So I was going to prepare some stuff before the stream, but then I thought that maybe I'll just do everything on stream. So yep, I didn't even create a directory for the project. Let's what's this called? WebGPU demo. So yeah, I said I'll upload recordings to Twitch, but I don't think Twitch allows you to just upload a random video, so I guess I'll upload them on YouTube instead. We'll see. Yeah, what I was going to do? Yeah, so I'll have the source in here. By the way, I'll upload the source code later to GitHub, of course. We'll have the source here, and then I'll put some libraries nearby. What I was going to do? Oh yeah, initializing Git repository, make a make lists file, lists. Okay, great. Open this thing with Git creator. You can use any IDE you want, of course. It doesn't matter at all, as long as it supports. This will do. As long as it supports CMake. GPU demo CMake required. I always so you are supposed to write this line in any CMake list, but I always just slap a random CMake version here. I think this will do. I don't remember what the CMake version is right now. Oh, it's 3.26, so I think 3.2 will do. You can use 3.5. I don't know. What's your favorite number? Let's make demo main CDP. Yeah, great. We need the. So the way I like to organize code is to have a dedicated source directory. Makes sense, I guess. Then we reload CMake with. Oh yeah, it's called source/main CDP. Okay. That's not particularly interesting. Okay, yes. So we need. Yeah, by the way, I made a Trello board. We can close that with this project. So I'll make it. I think I should make it public, I guess. I think I can do this off stream later. So the first thing I want to do is create a window with SDL. So let's include SDL to SDL.bash. It is somewhere in my system, so we just included it without any problems. How do you make it? SDL, you do init SDL init video, I think. Yeah. And then you just do create window. Please help me. Yeah. WebGPU demo. Del window was unspecified, I believe, undefined. Okay. Width, height, I don't care really. Let's do it like 1024 by 768 and window. Let's not make it resizable first, we'll make it resizable later. And let's show it immediately, and let's use Vulkan. So WebGPU is implemented on native. It is implemented as a proxy to an underlying API, so we will use Vulkan for that. The window actually. And then yeah, this won't link because we haven't linked SDL. Well, the proper way of doing this would be to find it using CMake. Let's see if it can do this. And package SDL2 required. Oh, it did actually find it. Okay. Target link libraries WebGPU demo SDL2 or something like that. Oh, that's it. It's weird when things work on the first try, isn't it? Okay, so we've made a window. We need to make the loop. We are running while running. Actually, we can make it look a bit nicer by turning it into a for loop. We will handle events here. Well, actually, we need to handle the quit event, so still all events switch and type. Yeah, still quit. Equals false. Right. Yeah, I think that should do it. And we don't render anything, so we will just leave this empty. Yeah, well, since we are not rendering anything here, that's our window right here. It is invisible. Well, it's not invisible, it just has some garbage. I can... Okay. So we have a window. It uses Vulkan. I thought you would need to link Vulkan implementation as well, like libvulkan.so or something like that. Do I have something like that on my system? Vulkan. Yeah, there are many. But I guess SDL just loads it at runtime or something like that. Okay. Now to the hard part. I want to take wgpu-native, which is a library with C bindings to WebGPU, which is a Rust implementation of WebGPU, which is a JavaScript API. I hope it makes sense. So I will just take the latest release and just download it. Linux, I think release will do. And when it downloads, we will just unzip it somewhere over here. Yep. GPU Linux release. I'm not not sure if I had the latest release. Let's make a directory of all that stuff. Okay, great. So we have the binary version of wgpu in the wgpu-native directory. Now we need to somehow link it. I think what I will do is, there is a find library thing. I don't remember how to use it. So what is var? Cache entry is created to store the result of this command. If the library is found, the result is stored. Let's just do okay, wgpu native, and then you say how's it called? wgpu native names wgpu native, and I think I will add a directory for CMake to search for this thing. Actually, let's do it. You know what? Let's do it like this. Hints. wgpu native root slash, just like that, and then we will set up this variable. How do you do that? No, it's not a string. No. A directory. Where did you put it? Oh, it's here. Which is okay. This one. Let's see if this works. Yeah, it says not found because I guess it didn't. Yeah, for some reason it just ignored the fact that I've set this directory to something. Let's do this. Why is it unset? What's wrong with you? Okay, I'll do this from the command line. .inst GPU native root equals there. GPU native. Yeah, so it found it. But if I do that from here, it. Okay, let's just. I don't know what is it doing. If I set it from the command line, it works, but if I do it from the from here, it doesn't work. Okay, what I will do is just additional CMake options. I'll just do it here. Yay, finally. So it finds the library, but I also want the include file. Yeah, so make find include directory, maybe something like that. Or is it find path? Yeah, probably find path. So find path. wgpu-native library, let's call it like that, and wgpu-native include directory. Means this thing should contain what? Yeah, the webgpu.ush file. So webgpu.ush. We will set the same hint here, and let's see what does it find. Oh, it found the directory. Great. So we can just do wgpu native library and include directories webgpu demo. Yay! Now we should be able to. Oh wait, we need to say it's public. Yay! We probably there is a make cache file. Wait, what? Oh my! I accidentally called cmake in the source directory. That's bad. Let's remove some stuff. Make files. Make install. This was all created by colon cmake here. Okay, let's build it one more time. Yeah, okay. What was I doing? Yeah, now we can finally start doing some WebGPU. So we have a window created by SDL, and we need to create a WebGPU surface connected to this SDL window. I think SDL doesn't support that out of the box, but I think I have an idea of how to do that. But first we need to what? I don't remember. Let's go to the Learn WGPU Native site. I think it was this one, yeah. The adapter. Yeah, that's what I want. I think we need to create the instance. So let's just do wgpu create instance. Yes, we need a wgpu instance descriptor. Okay, wgpu instance descriptor. Let's call it like that. So I guess it has a bunch of fields that we need to set. No, probably not. Just the next engine pointer. Create this thing, and it returns a WGPU instance. Great. I guess it is a proxy to something else. Yeah, it's just a peg pointer. Let's print it. It will just print a pointer, but if it's not 0, we should be fine. Oh yeah, the window just opened. Yeah, it's some pointer. Okay, makes sense. Let's do this. Then we need to create an adapter, and this one is a bit finicky. Yeah, the idea is that in JavaScript you would await it. So you would, it will be a kind of an asynchronous operation, while, yeah, there's this thing in C++. Okay, so wgpu adapter, because it is a method of the adapter, and then we do request, no, instance. We need a method of instance which creates an adapter. Okay, instance adapter options. We'll just do that. Some options. Request adapter callback, and user just request adapter callback user data. Okay, so we need wgpu request adapter options. This one should be quite large, yeah. There's a bunch of options we need to set. So next we'll change null pointer. Compatible surface. Now, what's that? What's the surface? Oh, do you need to create a surface first and then create an adapter? I thought all game devs use Windows. Did you build the traffic sim on Linux? Yep, I did. I use Linux. I don't even have Windows. I have some special Docker containers for building stuff for Windows using the MinGui v64 compiler, which cross compiles from Linux to Windows. Not even for games. Yep, not even for games. I mean, I don't play that often these days. I usually make games, not play them. So yeah, I guess you need the surface first. Yep. What do we do here? Options. Yeah. So we need to create a surface to render using this adapter. Okay, so we need a surface. Let's comment that out. We need a surface first. Now, the Learn wgpu site has a special extension for creating a WGPU surface from GLFW surface or window, probably window. I think if we almost copy that code, it should work. So we need to make a WGPU surface from a WGPU instance and SDL window. So let's call it SDL WGPU create surface. We need a WGPU instance and SDL window. So I'm on Linux, I'm on X11, so we need this code basically. But first I will check. Hi all. Hi. We've just started. we only have a window that doesn't draw anything. It even doesn't clear itself. Okay, so I think there is a way with SDL to check get native window handle to check which platform you're on. Yeah, this function probably. So we create a SDL sys VM info struct info. Then we do SDL get sys something something. No, not system RAM. Do we need to include something for that? Yes, this file. Get sys. No, how is it called? Get window VM info. Yeah, window info. I think you need to set the caller must initialize the infrastructure version by using this macro. Okay, weird, but okay. And now it has some info, like what? Something is wrong with this documentation. But okay. Oh yeah, that's it. So we can do switch info subsystem case SDL sys x11 do something, otherwise throw exception. Something like that. So here we do it should have info x11 display and the window. Okay, and that's all we need. And then we just copy this code. So the display is info x11 display, and the window is info x11 window. What's wrong? Taking address of a temporary object. Oh, yeah. Okay. So we need to create it actually on stack. Surface descriptor. Label no pointer. Let's create this thing first. I will leave this verbose names. Chain type WebGPU type from Xlib window. Whew. Then we set the window to this and the display to this. Oh. Now we need to create this thing and set the next in chain is the address of this thing. What's wrong? Oh, you need to cast the pointer, I guess. Okay. This is a weird way that wgpu uses. I think Vulkan uses the same thing to basically support extensions you define an object which has next in chain pointer which points to the extension, and this extension can point to another extension and so on. Something like that. So we need to do this formatting. Oops. We can finally do this and create a surface. So GPU surface equals still WebGPU create surface instance window. Now the surface will also be an opaque pointer, so we will just print it. If it is a reasonable pointer, we are good. I guess it is a reasonable pointer. I don't know. We can now create the adapter. So the compatible surface is surface. It has a power preference. What's the power preference? Let's set it to high performance. GPU power preference, high performance. Backend type, yeah, this one is important. We are using Vulkan, so GPU backend type, backend type Vulkan. Force fallback adapter. It is a wgpu bool. What's a wgpu bool? Well, let's just set it to false. Okay, we have the request options. Now we need the request callback. What's a request callback? Function with this signature. Request adapter callback. When did the stream start? Almost exactly at 5 p.m. UTC. Yeah, something like that. How different is Vulkan from OpenGL? Oh, it is much more lower level, I guess. I mean, in OpenGL, you can make a triangle in about 30 lines of code if you're generous. With Vulkan, you need something like 1000. And in WebGPU, you need something like 200. So message adapter status. Yes, so we can you be jumped to learn in Vulkan without knowing OpenGL? You can. It will be painful, like extremely painful. But if you have enough patience, yeah, you can, definitely. But I would suggest WebGPU first. It is painful as well, but not. It is something like an order of magnitude less painful. What are we doing? Oh yeah, so we need to create an adapter. We created a surface, which is the most important thing, I think. Adapter. So this thing works as a typical C callback. So the callback itself is a C function, and C++ lambdas can just automatically be converted to C functions, to C function pointers. But we need this function to write into this adapter. It needs to basically store this argument into this outside variable, and the way we will do this is by passing this variable address as the user data. And we will cast this pointer user data to the adapter. Now we need to check the state. What's wrong? What's wrong? Assignment to cast is illegal. What? What? Oh, yeah, okay. Missed one pointer dereferencing. So we need to check the status. Was the adapter actually created? Yeah, incredible success, unavailable error, and unknown, whatever that means. Okay, so if status equals wgpu request adapter status success, we do this. Otherwise, we throw a runtime error with a message. I think this should be fine. This function probably doesn't return anything. Yes, so let's probably log this message anyway. Back message. So no message. What? I'm confused. Oh, probably it was a yeah, so the message pointer is 0 and this messed up with the string, so let's do something like if message, then just print it. Otherwise, don't. Yeah, so this is kind of an asynchronous thing. Like it is supposed that this callback will be called at some point in the future when the adapter is ready, but in reality it will be ready immediately. So we can just do something like this. We know that this is a pointer, so that's safe, and then we can just well, let's not assert, if not adapter. Let's throw an exception as well. Whew. Still nothing on the screen, but we are getting there, I promise. Yeah, we had the surface inspecting the adapter. Oh, that's a good thing. So we can grab some features from the adapter. No, what is it? Yeah, wgpu feature name. I didn't include the vector. Features. wgpu adapter enumerate features adapter. This is our adapter. No pointer, and it will return the number of features this thing supports. So we resize the vector to this size, and then we call this function again, and it fills the array of features. Right? Yeah. And then we can just log these features. Feature dot what? Feature name. What's a feature name? Oh, it's a num. Well, okay, so we can just do that. We will have to compare the values of this enum to what we see in the logs manually. Oh, nice. A very nice list of features. Let's see what this means. So 0 is undefined, 1 is depth keep control, okay. Depth 32 float stencil 8 is a texture format, that's good. Time step query, that's really good. This will allow us to measure the time it takes for some things to happen on the GPU. Texture compression formats 4, 5, 6. Only 4 is supported on my instance. Well, okay, at least one. Indirect first instance is a thing for indirect rendering. Shader F16 half floats are not supported on my device. Well, okay, wasn't going to use them anyway. RG11B10U float renderable. Some weird format is renderable. Great. Float 32 filterable is not set. This is sad. This is sad. But okay. So what's that? I have no idea what that is. Let's look at this function. Maybe there is another. No. Okay, so I don't really know what this is. Oh, we can go to the WebGPU documentation. This one. No, not this is the shading language. We need the API itself. So we need to enumerate features. No, how was it called? Adapter enumerate features. Yeah, is it case sensitive? Wait, no, that's weird. Buffer as textures. Adapter. Maybe we need to look at the wgpu itself. wgpu core, I believe it's called. Let's just do this. Yeah, this thing. Where are the docs? Here. Documentation. So we need, yeah, the adapter. Enumerate. No, where is it? It is just features. Features must be explicitly requested in request device in order to use them. Okay. We have seen all these. Oh, here are some things that I didn't see in there. Okay, so wgpu-native has some other values here. Okay. Okay, we'll deal with this later. At least we know what these other features are. They're not supported by the WebGPU, but they are supported by the native implementation of WebGPU. Okay, makes sense. Where are we? We have created the adapter, we need to create the device. Let's just, yeah, so you need to do basically the same thing. Requesting a device is also done using an asynchronous function. Request device. Okay, let's do adapter request device. Yeah, we set the adapter. Device descriptor, we need a device descriptor, wgpu device descriptor, we will fill it with stuff soon. It's not towards ter. Request device callback, request device callback, I don't care, and the user data will be the device itself, so that we can rewrite it in the callback. So let's go see what the type of the callback is. It is this. I think we can almost exactly copy everything. The callback we have written earlier. Request device callback is a lambda with this thing. Okay, copy that. It's not an adapter, it's a device. Success. It's not an adapter, it's wgpu device pointer, and we have a device here. Nice. And yeah, so now we need to fill in this descriptor. What does it have? That was confusing. It's not supported by the WebGPU, but implementation has them. Yeah, wgpu-native is a native implementation of WebGPU, and it has some extensions that are not supported by the original WebGPU. Just because there are stuff that that is really useful on native, and which might be questionable on. Well, not might be questionable, which is not really supported by all browsers or something like that. If we look at the, so we have the webgpu.hash file, we have also the wgpu.hash file, which has some extensions. And it has some stuff that is not in the original WebGPU, so like it has some extra functions, like stuff like push constant. Yeah, for example, push constants, multi-draw and direct, some pipeline statistics queries. Yeah, we needed the device descriptor. Okay, let's just copy all its fields. So next in chain is null pointer, We're not using any extensions here. Label can be 0. It is basically just a name for this object for debugging purposes. Requested feature can, oh yeah, we can request some features here. We won't do that for now, but in the future it might be an important thing to do. So these things, if we are going to use any of these, we will need to explicitly request them here. Required limits, oh yeah, the limits. Let's do this. Required limits, required limits. Also a fun struct. Where was I? Wait. Yep. Next in chain, null pointer, and the limits itself is a big struct with a bunch of settings. I don't really feel like filling this out myself, but I believe you can do something like wgpu adapter. Get limits, yeah. You supported limits, null pointer. And then we do adapter, supported limits. Yeah, so we ask what limits are supported. And then in the required limits, I will just set the same limits. By the way, let's print them probably. Well, a bit later. So, device descriptor, required limits. Device lost callback, I will just set it to null pointer. I don't think device can be lost on desktop. It is something for the web or for mobile platforms. Like, I hope it is. Q descriptor. Oh, yeah, we need GPU Q descriptor. And just fill it with null pointers. I could use some C++ wrapper around all this stuff so that I don't have to do all this, but I like to get my hands dirty for a while when I'm learning the API. Well, what's wrong? New descriptor. Oh, we didn't need to. Okay, it is not a pointer, it is a struct, so we can just set it here. We don't need it here. Okay. Now we should get a device. If not device, device not created, and log it. We have the device. Okay. Now we have this supported limits. Let's actually print them. So I will do some hacks here. Yeah, unfortunately, Qt Creator doesn't know how to do smart multi-line editing, so I will do something really stupid right now. I will open this file in Vim. Yeah, and I will do some magic. Yep, great. So yes, reload the file. Yay, we have the thing. I hope it compiles. Let's say that these are supported limits, just for fun. Let's see what our WebGPU is capable of. So maximal texture dimensions, maximal texture array layers, bind groups, and so on and so on. Max samplers per shader stage. That's a ridiculous number. Max uniform buffers, max vertex buffers. 32 vertex attributes. Yeah, okay. Max color attachment 0. That's weird. Okay, we'll deal with this later. We have created a device. We are almost there. We almost have a screen that has something on it. So we need a command encoder. First color, let's go to the first color thing. Oh yeah, we need to create a swap chain. Okay. Yeah, let's start with that. We will need to know the size of it, so let's say width equals height equals something. Now we need to create the swap chain, so wgpu adapter, no, device, create swap chain, no. How do you create a swap chain? Oh yeah, it's not a structure, it's a function. Create swap, no. That's weird. If we ask for swap chain here, swap, nothing. this thing has nothing about swap chains. That is weird. How do I create it? Yeah, I see it. So if we removed the explicit manipulation of swap chains. So how we are supposed to do it then? Can create buffers, blah blah blah. That's weird. So I guess if we look for swap chains here, we won't see anything else. Relevant. Let's see. So we need something like configure. Oh, so you need to configure the surface. And you just get the, and then you tell it to present. Okay, yeah, I guess that's how you should do it. Thank you. What are surface capabilities? Formats, present mode count, present modes, blah blah blah. Okay, so I guess we need to do it here. Where's the surface? We have the adapter. Oh, here's the surface. So wgpu configure surface. wgpu surface configure. Yeah. Surface configuration. Chat GPU. That would be funny. Yeah, it is a bit easier to set up on JavaScript side, I guess. So what's surface configuration? We need a bunch of stuff here. Oh, we need the device to configure it, so I guess we will do that after we created the device. 1 hour 15 minutes. Still no triangle. But we are getting there. So what's a wgpu texture format? I mean, I guess the good way of doing this is to do wgpu surface capabilities. So we will ask the surface what texture format does it want, and then we will select one of them. So I will set the format, wgpu texture format, so we'll set it to surface capabilities. Formats 0. If it doesn't support any texture formats, then we can't render on it, obviously. This doesn't support any texture formats. Texture usage flags. I guess that is somewhere over here. Texture view. Yeah, so we need to say that it is a render attachment, which makes sense because we are going to render into it wgpu texture usage flags, texture usage render attachment. What's a view format? Okay, let's do all the easiest stuff first. The present mode is wgpu present mode first in first out, which, as I understand it, is just the usual like vsync enabled thing with double or triple buffering. Alpha mode. Let's set it to auto. I have no idea what that is. GPU alpha mode. No. Yeah, this one. Now, what are these view formats? Does this have something about them? Oh, that's probably the thing. No, it isn't. Do we have this function, by the way? Oh, we do. So we don't need to ask for capabilities. We can just ask for the for the preferred format. Okay. Now, what's up with this thing? I mean, I guess it will be the same. So we can configure the surface. I hope it doesn't crash. It didn't. And then to actually render on it, we get current texture. And then we probably present. So view texture, view, something like that. No, it's not a texture view, it's a surface texture. Surface texture. Surface texture. Surface texture, and then we probably do surface present surface, and then I guess that this is where we actually render something. Oh, surface image is already acquired. So let's see. I guess you get the texture view. This is roughly what we did. Oh, you need to release it explicitly. Okay. View is texture release. How do you release it? Oh, it's not. It's not a WebGPU object. It has a texture. It has a bool suboptimal. Surface gets current texture status. Oh, interesting. So if surface texture status is not equal to WebGPU surface texture status, or what? This thing. So if it's not a success, can't get surface texture. And then we release the texture. Oh, it's texture release. It's method. It's the object name and the method name. Okay, base texture. Which WebGPU implementation are you using? The wgpu-native, the C bindings to wgpu, which is written in Rust. Surface which is already acquired. Let's go to the docs. Device. Surface. Where is the surface? Here. Next texture to be presented by the swap chain. In order to present, first it needs to be done with some work. Then, if a surface texture reference in this surface is alive, wait, maybe do I need to no, there's no way to release it. So you release the texture itself. If a surface texture reference in this surface is alive when the swap chain is recreated. No, that's not a problem. It needs to be built after any work when the texture is scheduled via queue submit. Image is already acquired in the surface present. I mean, what if we don't acquire texture? Will it panic? Surface image is already acquired. Surface image is already acquired. Let's search this exact error. Great. No results. Run with Rust backtrace. Well, let's do it. Debug. WGPU. So just Rust unwind, panicking. This is pretty much useless, but maybe it isn't. We have the file here. No, I don't want to read Rust documentation, to read Rust source. Yeah, setting, just using the version from the tutorial will work, but I just want to do something, you know, future-proof. So if something changes in the WebGPU native, I want to basically use that. Needs to be called after any work on the texture is scheduled. Surface texture present. Wait, what? Yeah, so there's only one present function here, and it works on a surface. So, and when we do that, we surface image is already acquired. I mean, this was a success, but let's see what frame number it is. Yeah, it fails after the first frame, so we are doing something wrong. I know it worked in the older version with the swap chains because, well, I did it a few months ago. A few rotating textured quads, I believe, and it worked. So it is not where we're just missing something. So we configured the surface for this adapter for this device. Let's maybe log the surface format. Just in case. 24, which is it was in decimal, so in hex it is 18, right? BGRA8 enormous RGB, pretty normal, pretty good format. View format. Let's look at this surface configuration thing. So maybe we missed something. Surface. Configure initializes for presentation. So usage formats, view formats. What's the view formats? What will be allowed when calling create view on texture returned by get current texture? View formats of the same format as the texture are always allowed. Maybe, wait, maybe we don't need to release the texture. Oh, yeah, okay, we didn't need to release the texture. I guess you create a texture view from this texture, and this texture view should be released, but not the texture itself. Great. And now, after 3 frames, we can't get surface texture. Let's just print the stages as well. I am pretty sure that it will be no, I don't know what it will be. 1. So what's 1? 1 is timeout. Oh, yeah, that makes sense. So it's using triple buffering, and since we are not rendering anything, we are requesting swap chain images so fast that we just have no images left. So what? I mean, I don't think that the issue is that I didn't render them. I mean, I did render them. It's just that my render was an empty operation that does nothing. I think we need to wait here or something like that. You know what? If the surface status is timeout, I will just do a hot loop here. I don't think that's a good idea, but it should have some waiting function, like yeah, so if it's timeout, we just wait. If it is not a success, otherwise we throw, and if it is a success, we just let's see what you should do if it is a timeout. Get current texture. The error is here. Timeout outdated, lost out of memory. A timeout was encountered while trying to acquire the next frame. So I mean, what if we just oh, this works. So maybe present the surface, but not the surface texture. As I understand it, surface texture is not really a thing. It's just a bunch of stuff. It's really just the texture, and it doesn't have any methods really. So there are no methods here saying something about surface texture. You know, it's just a type, and that's it. So it's not an object in the API. The doc says the surface texture present needs to be called. Well, I guess. Let's wait for a while and see what we get. Oh, I closed Qt Creator. Oops. So we got timeouts here. Why did it only render so few frames? Yeah, this is set by the docs, but the C++ interface doesn't have this. It only has surface present, not the surface texture present. Surface. Yeah, and the surface doesn't have a present function anymore in the Rust version, at least. Let's see in the so like this release was 0.18.13. Can we just oh, I see. So we probably need okay. No. Let's get the documentation for the latest version. Development branch. Maybe. Structs. Surface. Yeah, they say that it has a present method and the surface doesn't. This is all really confusing. One hour, 41 minutes. We haven't even cleared the screen yet, but we are getting there. Yeah, better understand what we are doing. I agree. Okay. Texture destroy, texture, texture, texture. Oh, so we can see that there is a 1 second timeout. Okay, that makes sense. So we kind of what if we destroy the texture? I don't think that's a good idea, but let's try it. No, nothing changed. Let's not destroy it then. So it is timing out, meaning what does the tutorial do? Let's look at the resulting code. So in the main, they pull events, they get the texture. We are doing pretty much the same. They make a command encoder, then do the stuff. They release the texture view, not the texture. They submit a command buffer to the queue, and then they do that. Yeah, sure. Have a good day, night, or whatever. maybe the Rust thing has some examples. Yep, examples. So let's see. Hello. This will do. No, they're not doing anything here. Let's cube. I think this should show a cube. Yep. Let's find the present function here. Nope. Device, queue, adapter, texture view. I guess they have some initialization code in this example or something like that. Okay, let's just go to the examples and search in this path. Yeah. Present. This is a present mode, frame present. Oh yeah, framework Rust, that's what we need. So where do they do present? Frame present, what's a frame? Jesus. Surface wrapper. Resume, blah 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 blah, resize, acquire. Oh, that's one. That is an interesting thing. So they get the current texture. And then who calls that? Oh, frame is the acquired texture, so they window loop, window request redraw. Oh, maybe we need to do something here. Okay, so we'll find an example. Q submit, Q present. They have these files, and Q present does something. Q wait idle. Do we have something here that waits? No. No, we don't. Okay. Okay, let's look at the Vulkan tutorial. Maybe we need to call something like, you know, SDL swap buffers, swap window, but for a Vulkan enabled window. I mean, what if I just do that? Nothing changed. I guess this function just didn't do anything because we don't have an open shell window. So, drawing a triangle, base code, layers, presentation, window surface, swap chain. Okay, in Vulkan you need to explicitly wait until the images of the swap chain get free. I don't think we can do this here. Okay, let's try the following. Let's just at least we have our first 3 frames, or maybe 2 frames. Yeah, the timeout happened on the 2nd frame, so we are using double buffering, not triple buffering. Let's try to draw something still. So let's do something. We need the queue. This is the queue of operations that we do on the GPU. The GPU device get queue. Yeah. The GPU device has just one queue, so it's as easy as that. So we submit stuff to this queue by doing queue submit and creating command buffers. And to create command buffers, we need command encoders, and they yeah. So let's go here and do let's look directly in their code. Yeah, so on each frame we create a command encoder descriptor. We create a command encoder which we use to what? Where is it? Encoder. We use it to we use it to create an empty render pass. Okay, makes sense. Then we finish the command encoder, create a command buffer, which is okay. Okay, so let's go. wgpu command encoder. Command encoder. GPU device create command encoder. Device command encoder descriptor. Encoder descriptor, and we need this descriptor. So what do we need to specify? Oh, nothing basically. Just fill it with null pointers. We have our command encoder, and we can do wgpu command encoder begin render pass. Yeah, this thing. We need the encoder, and we need the render pass descriptor. This will be the important thing here. Render pass descriptor. The descriptor. I don't think it returns anything. Oh, it returns a render pass encoder. Well, okay. I guess. Almost 2 hours and we don't still have anything on screen. Yep, that's the modern graphics APIs for you. So we need a render pass descriptor. What's wrong here? Oh, we need to, yeah, the descriptors need to be passed by pointer. So I think this thing has a lot of stuff in it. So color attachment count is 1. Color attachments, occlusion color set. What do we do here? Nullable. Oh, we can just set it to null pointer. We can set the depth stencil attachment to null pointer. We are not using it right now, at least. Timestamp rights, we don't need them. We only need to specify the color attachment. There plus color attachment. So again, fill. It needs a texture view. It needs a resolve target. I believe the resolve target is for multi-sampling. Yeah, we can set it to null pointer. Okay, we need to create a texture view from our surface texture. So wgpu texture create view. Texture is surface texture. Texture view descriptor is okay. Texture view descriptor. What do we need to specify here? Oh, a bunch of stuff again. So the texture format will be the surface format that we asked for earlier. The dimension will be 2D. It's just a GPU texture view dimension 2D. Base meep level 0, I guess. Meep level count 0. We don't need meep levels for presenting to the screen. Base array layer 0. Array layer count 1, probably. I don't know. probably. Texture aspect. Stencil only, delve only, all. Let's do all. Okay, we have the texture view descriptor. We should be good with the texture view. Let's call it surface texture view. Let's also print it. Oh, I forgot to. Let's just pretend we didn't write all this code. Just look at the texture view, and then we will destroy it. Texture view release surface texture view. And invalid map level count. Oh yeah, you still need at least one map level. Yeah, so we got some texture views. That's nice. Let's continue writing that stuff. Where were we? Yeah, the render pass color attachment. We need all this stuff, so the texture view we are writing to is the surface texture view we created. The resolve target is null. The load operation is wgpu load op clear the screen. The store operation is wgpu store op store, and the clear value will be a color, which is just a bunch of doubles. Let's set it to magenta. Okay, so we have the color attachment, render plus color attachment. Now we should be able to create the render parse encoder, which oh yeah, we need to end it. wgpu render plus encoder end. Yeah, so this is where we would render stuff, but for now we'll be fine with just clearing the screen. After that we can release the texture view, not here, after we have finished rendering to it, and we create the so we need to wgpu command encoder finish. We have the command encoder, command buffer descriptor. So we have recorded the commands that we want to send to the GPU, and now we need to turn them into a thing called a command buffer. And we get a command buffer. Which we can wgpu submit q one command, this one. Again, do we need to? No, we don't. You don't need to delete this command buffer. I guess it is consumed by the queue. No way. Oh. Can you see it? Whew, so it is actually drawing frames. We can see that it is going really fast, so it means that everything is okay. I'm not happy with these pointers growing. I do release the the texture view, don't I? Yes, I do. Maybe I need to release the texture itself. Let's just try that. Service image is already acquired. Yeah, I guess we shouldn't destroy the textures, just the texture views. So this is a win. Yeah, that's good. That's good. We don't need to log this surface texture, but I will keep the frame numbers. So I guess if you don't submit any work to this thing, if you don't even clear it, which we've done here basically, it doesn't display anything to the screen, which I don't know if it makes sense, but probably it does. Okay, well, I'll make a git ignore file which ignores itself, my favorite trick, and I don't need the build directories or the file that Qt Creator created. Let's commit this thing. So 263 lines of code to clear the screen. That would have been something like 700 in Vulkan, I guess. Okay, I think it's enough for today. We spent 2 hours. Yeah, almost exactly 2 hours since we started. Thanks for everybody. I think I'll post on Twitter when I'll go in to do the next stream. I think probably tomorrow, or maybe the day after tomorrow, something like that. Okay, thank you. Bye.